It began with the smallest of tremors, so subtle, in fact, that most residents didn't even feel them. Just minor blips on the seismographs, dismissed at first as background noise in one of the world's most geologically active regions. After all, this is Iceland, a land where fire and ice collide beneath the crust, where volcanoes sleep under glaciers, and the very ground is known to shift and breathe with a kind of ancient rhythm. Earthquakes here are expected. But this was different. In early reports, scientists noted that the frequency of microquakes near the Reykjanes Peninsula had increased, not just in number, but in pattern. Instead of random, isolated quakes, they were forming chains. Pulses. Almost like footsteps. And deeper than usual. Most seismic activity in Iceland originates from the upper crust, a few kilometers below the surface. These new tremors, however, were coming from a place far beneath that. As if something massive, was awakening in the depths. At first, the data was puzzling, but not alarming. This is a land that straddles two tectonic plates, the North American and the Eurasian, which are slowly pulling away from each other, tearing the island apart at a rate of about 2 centimeters per year. Magma rises between them, building new land as old formations crack and shift. It's a violent dance, but one Icelanders have learned to live with. Towns are built on lava fields, roads snake between steaming vents, and geysers erupt beside cafes. But this new activity doesn't follow the script. The tremors are not just increasing, they're migrating. Not sideways, but upward. As if pressure is building from below, displacing rock in slow, unstoppable pulses. And with it, the land itself is rising. Sections of the peninsula have lifted several centimeters in a matter of weeks. That's not normal. Not here. Not anywhere. Volcanologists began referring to the anomaly as a deep intrusion. A strange term that carries an unsettling implication. Something is forcing its way upward through the Earth's layers. But even they can't say what, exactly, is rising. Is it magma from a previously unknown reservoir? Is it a swelling pocket of volatile gases? Or could it be the early signs of a long-dormant system stirring from a centuries-long sleep? Some have even suggested that Iceland may be approaching a geological tipping point, an event so large it could reshape entire regions of the country. These aren't fringe theories. These are leading experts in seismic forecasting, staring at real-time models that refuse to behave. In the words of one scientist, it's like watching a living organism change shape from the inside out. The implications are enormous. If the pressure continues to build, it could trigger a major eruption unlike anything Iceland has seen in modern history. If it doesn't erupt, the land might still continue to deform, altering coastlines, disrupting water tables, and fracturing critical infrastructure. Already, geothermal wells are reporting minor pressure changes. Roads near Grindavik have begun to buckle ever so slightly. Satellite imagery reveals shifts in elevation that weren't there last month. Something is moving down there, rising, expanding, pressing against the crust like a fist beneath a sheet of ice. But perhaps the most disturbing part: scientists don't know why. Every model they've run either breaks or contradicts what's already happening. The timelines don't add up. The temperature gradients are off. Gases typically present in magma-driven uplift, like sulfur dioxide, aren't being detected in expected concentrations. It's almost as if the Earth is behaving like a pressure cooker with the lid firmly sealed, but no one knows what's inside. Speculation has begun to spread like wildfire, even among the typically cautious scientific community. Could this be the birth of a new volcanic system entirely? Or worse, an interconnected chain reaction, where the pressure here triggers activity elsewhere, in a domino effect that could span the entire island? And as the world watches Iceland's ever-changing surface through satellites and drones, one truth has become impossible to ignore: something massive is shifting beneath Iceland. And not even the experts know what's coming next. Now, before we continue, please consider subscribing and liking the video to help support our team in making more videos like this. There's a growing murmur among scientists, quiet but persistent, that something monumental might be unfolding beneath Iceland's surface. not a typical event. Not just a cluster of shallow earthquakes, or the tremble of tectonic plates shifting minutely in the darkness. No, this feels different. This feels like a story much older and deeper is trying to push its way up from the mantle. Some experts believe the source of the ongoing deformation, the swelling land, and the quietly restless ground might be traced to the formation, or awakening, of a previously undetected magma chamber. One that is quietly expanding beneath the crust, slowly but steadily, inflating the landmass from below like a balloon being filled just a little too fast for comfort. What's so haunting about this theory is not just the idea that something massive is stirring underground, it's the implication that this process has been happening for much longer than we realized. That this chamber didn't suddenly appear overnight, but has been growing in secret for months, maybe even years, hidden in the silence, accumulating pressure in the darkness while we went about our lives, unaware that the earth beneath our feet was slowly changing shape. Magma chambers, for those unfamiliar, are essentially underground reservoirs of molten rock, vast pockets where magma collects before it either cools and crystallizes or, in more volatile scenarios, finds a path to the surface in the form of an eruption. Iceland has many known magma systems, especially around its active volcanic zones. But what's being proposed now is more unsettling: the emergence of a new chamber, one not previously catalogued, potentially forming in a region that was considered geologically quieter than others. And that's where things get truly bizarre. Because if this structure has gone undetected for this long, it suggests a depth or location that evaded our most sophisticated geological instruments, satellites, GPS arrays, seismic networks, thermal sensors. It would mean that for all our scientific advancement, the Earth still has the capacity to keep secrets. That despite decades of observation and analysis, we still don't fully understand what lies beneath the crust in certain regions of Iceland. And now, that ignorance may be catching up with us in the most dramatic way possible. Recent satellite readings, particularly those gathered through NSAR technology, have shown alarming patterns. Ground deformation is occurring at a rate that has shocked even veteran geologists. Entire swathes of the Reykjanes Peninsula have lifted several centimeters in mere weeks. That kind of uplift doesn't happen without an immense force beneath the surface. But it's not just the vertical motion, it's the horizontal spreading that's even more ominous. The landscape isn't just rising, it's stretching outward subtly, like a sheet of rubber being pulled from below. And the only realistic explanation for this type of widespread deformation, especially in the absence of surface eruptions or visible venting, is a deep, pressurized intrusion of magma. This wouldn't be a narrow conduit of lava like what we see during surface eruptions. It would be a massive, swelling reservoir, pressing outward in all directions, warping the overlying rock, and sending tremors rippling across the region as it forces its way into the crust. But perhaps the most disturbing aspect of this entire theory is how quiet it all is. Typically, when magma rises toward the surface, we get a warning. Gases escape. Harmonic tremors, those signature, rhythmic quakes tied directly to magma movement, set off alarm bells. We might see increased thermal output or volcanic steam vents activating. But not this time. Here, the Earth is whispering instead of shouting. The seismic activity is scattered and inconsistent. Low-frequency tremors, often so subtle they're nearly lost in the ambient geological noise. There's no spike in sulfur dioxide emissions. No significant change in geothermal well activity. And yet the land continues to lift. The pressure continues to build. This type of quiet inflation is characteristic of deep-seated magmatic activity. A slow, insidious process where magma seeps laterally into cavities and fractures, creating enormous underground bulges that might not erupt immediately, or ever. Instead, they lie in wait, gradually distorting the landscape, and sometimes destabilizing surrounding faults in ways that could lead to future disasters. Some geologists are now entertaining a far more exotic possibility: that this new activity is being fueled not by any known chamber, but by a shift in the Icelandic mantle plume, that ancient upwelling of superheated rock rising from the Earth's core mantle boundary, believed to be responsible for Iceland's position atop one of the most volcanically active regions on the planet. This plume is what gives Iceland its geothermal energy, its lava fields, its volcanic islands. But what if it's changing course? What if, deep beneath the crust, the plume is realigning, directing its energy into a previously inactive zone? That would explain the sudden swelling, the lack of historical precedent, and the emergence of seismic activity in areas that haven't seen this kind of unrest for centuries, if ever. It would also mean that Iceland is undergoing a fundamental geologic reconfiguration, one that we can't yet fully see, but that will shape the island's volcanic future in ways we can't predict. It's not just academic. The implications of a growing, hidden magma chamber are staggering. If it continues to expand, we could be looking at increased seismic risk, surface fissures, gas venting, or even a full-scale eruption down the line. The problem is, we wouldn't know where to expect it. This isn't like monitoring an established volcano with a known caldera and eruption history. This is uncharted territory, a system with no established pattern, no predictable behavior. And because of its hidden nature, we might not get the kind of warning signs that typically precede eruptions. Instead, the first real indicator could be a sudden, violent event, a rupture, an explosive decompression, or an unexpected lava field ripping through the landscape. Until then, we're left with clues. Subtle ones. Faint tremors. Slight changes in geothermal pressure. Land that doesn't lie still. The ground is whispering, scientists say, but most people aren't listening. Those who are, they're trying to map the movements of a force that's invisible, underground, and possibly on the move. The longer this chamber grows unchecked, the more likely it becomes that Iceland is standing on the edge of a transformation, and the rest of the world might not be far behind in feeling its effects. One particularly haunting aspect that has begun to preoccupy geophysicists isn't just the presence of the magma chamber itself, but how eerily symmetrical the deformation patterns appear to be. As data pours in from ground-based GPS sensors and satellite imaging, what emerges is a disturbingly clean concentric uplift pattern, something that, in geological terms, implies a centralized pressure point directly beneath the region. This level of symmetry doesn't often happen by coincidence. It suggests not just the presence of magma, but a massive, singular intrusion, rather than multiple, scattered dikes or minor flows. It's as if a balloon is being inflated precisely beneath the epicenter of this activity, causing the ground to swell like a dome. And what's more, this isn't a typical surface bulge you'd associate with a shallow chamber preparing to vent. This is deep, smooth, and wide, indicating that the source may be tens of kilometers down, moving slowly and methodically, like a deep breath being held far beneath the crust. And this leads to a darker, more chilling possibility, that the chamber isn't just forming, but stabilizing. In volcanic systems, there's a significant difference between magma that's on its way out and magma that's content to remain underground, slowly pooling and gathering strength. A chamber that stabilizes can remain pressurized for years, even decades, without erupting. But in that time, it doesn't stay dormant. It evolves. It cools unevenly, creating fractures and shifts in density. Gases become trapped in pressure pockets, separated by walls of slowly crystallizing rock. These stratifications can turn a benign reservoir into a powder keg, capable of producing explosive eruptions if the chamber is disturbed or if external tectonic forces eventually breach its containment. The fact that no venting has been observed might not be comforting. It might mean that the system is still sealing itself, growing more dangerous the longer it remains silent. Scientists have also begun studying anomalies in the regional gravity field. Gravity measurements can reveal mass changes beneath the Earth's surface, and recent scans over the suspected zone show subtle but consistent gravitational shifts. This implies that dense magma is displacing lighter rock layers, altering the local gravity signature. These changes are so nuanced that they wouldn't be noticeable to the naked eye or even typical instruments. But to trained geologists, they tell a story of movement, a slow churn of molten rock migrating into spaces it was never meant to occupy. And the question becomes, where exactly is it going? Because if it's breaching older volcanic structures that have long since cooled, or moving laterally into weak zones of the crust, Iceland could be on the brink of an entirely new volcanic regime, one that might not resemble anything seen in the island's recorded past. The idea of a new magma chamber forming isn't just about lava. It's about heat, and the way it warps everything it touches. Deep beneath Iceland, temperatures could be rising by hundreds of degrees in localized pockets, weakening rock formations and allowing microfractures to spider out in unpredictable directions. This thermal pressure doesn't just stay put, it radiates. It softens the base of tectonic blocks, destabilizes fault lines, and may even trigger hydrothermal explosions, where groundwater suddenly flashes to steam under extreme conditions. And none of these things require an eruption to be dangerous. An underground steam explosion, if it occurs near the surface, can send boulders and debris flying like shrapnel. If it happens deep underground, it can carve out enormous voids, collapsing the surface without warning. What's unsettling is that Iceland has thousands of such hydrothermal pockets, and this expanding chamber may be reactivating some of them, silent fuse boxes waiting for the right combination of pressure and temperature to go off. And still, beneath all of this speculation, remains one unavoidable truth: we can't see it. The magma is hidden. We know it's there, but we don't know its exact size, shape, or behavior. It doesn't emit a clear signature, and it hasn't pierced the surface to reveal its nature. So we're left relying on indirect evidence: the way the Earth moves, the shifting weight beneath our feet, the thermal energy rising where it shouldn't. It's a bit like trying to map the shape of a monster by watching the way water ripples around it. You might sense its form. You might catch glimpses of its outline. But you never see the thing itself, until it wants to be seen. That's the position Iceland's scientific community finds itself in now. They know something colossal is forming. They know it's active. But its full dimensions remain a mystery, a riddle buried beneath layers of ancient basalt and hardened lava flows. What adds an even more surreal dimension to this growing fear is Iceland's own complex relationship with fire and ice. This is a land that was born from the clash between tectonic forces and volcanic heat. The people here live with volcanoes the way others live with storms or seasons. They are used to ash in the air and lava on the move. But what's happening now feels different. Even the veterans, the volcanologists and seismologists who've spent decades reading this land like a living manuscript, are hesitant to make predictions. They speak cautiously in interviews. They avoid absolutes. Because this isn't a known system waking up. It's a new force emerging, reshaping the ground rules as it goes. One that isn't confined to the boundaries of known volcanic systems, and that may not follow any historical pattern. The possibility of a long silent volcanic region becoming active again as a result of deep magmatic pressurization is one that's gaining traction in academic circles. There are whispers now about areas in southwestern Iceland that have no eruptive history for the last 1,000 years, but are now beginning to show signs of thermal anomaly and microseismic unrest. These are places no one ever expected to wake up. If the expanding chamber begins to exert lateral pressure, it could activate faults or melt rock in regions that weren't even on the radar before. Suddenly, the risk isn't limited to one eruption site. It becomes a network of unstable zones, all quietly reshaped by a magma system that's spreading unseen beneath the country like a slow-moving tide of fire. While the idea of a massive magma chamber is as captivating as it is unsettling, it's not the only theory making waves in scientific circles. In fact, some researchers are proposing an entirely different culprit, an unexpected reactivation of a buried fault system, a deep tectonic fault that has remained dormant for centuries, possibly even millennia. This theory suggests that what's shifting beneath Iceland may not be volcanic in origin at all, but tectonic, an ancient geological scar stretching across the island's underbelly, now stirring after a long and eerie silence. And if this is true, it opens up a new chapter in Iceland's geological story, one that involves not fire from below, but the grinding of Earth's great plates and the awakening of forgotten fractures. To appreciate the gravity of this theory, we need to step back and understand the tectonic character of Iceland itself. The island straddles the Mid-Atlantic Ridge, a massive divergent boundary where the North American and Eurasian plates slowly drift apart, tearing the crust open and allowing molten rock to rise from the mantle. But this boundary isn't a single clean line. It's a tangled web of smaller rifts, faults, and fracture zones, many of which were formed millions of years ago during chaotic bursts of tectonic activity. Over time, some of these faults became inactive, sealed by cooled magma or compressed into dormancy by shifting stresses elsewhere. But they never disappeared. They've just been sleeping, buried under layers of volcanic rock and glacial sediment, forgotten relics of an older Earth, until now. Recent seismic activity, however, has begun to raise eyebrows among geologists. The tremors being recorded across southwestern Iceland don't always align with known volcanic centers. In fact, a surprising number of these quakes are occurring along a jagged, previously subdued line that cuts through the landscape in a subtle arc, invisible to the naked eye but unmistakable in the data. These quakes aren't especially powerful, yet, but they are consistent, and they are increasing in frequency. What's more, they seem to occur at depths that don't match typical magmatic movement. Instead, they suggest deep crustal shifts, a flexing and grinding of ancient rock against rock, as if the Earth is trying to tear open a path that hasn't been used in thousands of years. This has led some researchers to suspect that a buried fault system, one that predates many of Iceland's modern volcanic features, might be waking up. And the implications of that are deeply unsettling. Unlike volcanoes, which often give off warning signs like heat, gas emissions, or surface deformation, tectonic shifts can be stealthy. A fault can move for months or years in small increments, releasing its stress in slow tremors known as tectonic creep. But if that stress builds up too much, if the rock resists movement until a critical threshold is crossed, then it can snap violently, unleashing a major earthquake without much warning at all. Iceland isn't typically associated with massive tectonic quakes, but if this ancient fault system truly is reactivating, then the rules may no longer apply. We could be looking at the emergence of a new seismic threat, one that doesn't follow the familiar rhythms of the island's volcanoes. This theory gains even more traction when we consider the strange tilt recorded by multiple GPS stations around the presumed fault zone. Instead of a simple upward bulge, which would suggest volcanic uplift, the land is shifting in complex directions, some areas rising while others sink slightly, like pieces of a jigsaw puzzle being pulled apart unevenly. These multidirectional movements are classic indicators of tectonic deformation, and the patterns are eerily similar to those seen in regions like California or Japan, places notorious for hidden faults that suddenly rupture after centuries of inactivity. In Iceland, such an event would be unprecedented in the modern era, but not impossible. In fact, some of the island's most devastating historic events, like the 1784–85 Skafta fires, were accompanied by significant ground fractures that may have originated from tectonic shifts rather than pure volcanic activity. Adding another layer of intrigue is the role of glacial rebound, a slow-motion process that's subtly reshaping the Icelandic crust. Over the last century, Iceland's massive glaciers have been steadily melting, thanks in part to climate change. As they retreat, the enormous weight they once pressed onto the land is being lifted, allowing the crust to slowly spring upward. It's like removing a boulder from a trampoline. At first, the surface shifts gently, but over time, it can rebound with considerable force. This process, known as isostatic adjustment, doesn't just change the surface, it redistributes stress deep in the crust. And according to some models, this rebounding may be applying new pressure to dormant faults, essentially flipping the switch on ancient zones of weakness that haven't felt movement in thousands of years. In other words, climate change may be doing more than melting ice, it may be reactivating the Earth's old wounds. If this tectonic theory holds true, then what's happening beneath Iceland isn't a single event, but part of a much larger and more gradual transformation. The island's very foundation may be shifting, redistributing its seismic stress, altering the balance between volcanic and tectonic forces, and changing the geological script in ways that even experienced scientists are struggling to interpret. It raises questions we aren't ready to answer. What happens if this fault continues to awaken? Could it interact with volcanic systems above it? Could it redirect magma flows or create entirely new zones of volcanic risk? And most haunting of all, how much of this is already in motion, hidden from view beneath miles of rock? The reality is, even with today's technology, we can't see through the crust with perfect clarity. We're left with scattered clues, quakes, shifts, data points, all suggesting that something enormous and ancient is stirring beneath Iceland's feet. Whether it's magma, tectonics, or a tangled interaction of both, one thing is certain: this is only the beginning of the mystery. But what if the tremors, ground shifts, and swelling landscapes are not purely volcanic, and not entirely tectonic either? What if something else is stirring below Iceland, something more elusive, more fluid, and far less predictable? As scientists exhaust the traditional explanations of magma chambers and ancient fault lines, some have begun to whisper a third possibility. It's a theory that doesn't revolve around the grinding of plates or the rise of lava, but rather, the underground migration of superheated fluids, an invisible tide of mineral-rich water and volatile gases moving silently through the island's crust, altering everything in its path. At first glance, it might sound anticlimactic. How could water, of all things, be responsible for the massive and mysterious deformation of an entire region? But deep within the earth, water isn't the tame, gentle force we know on the surface. It exists as supercritical fluid, a strange, hybrid state where liquid and gas blur into one. Under extreme heat and pressure, like those found several kilometers beneath Iceland, water transforms into something altogether different: a dense, energy-charged substance capable of carving tunnels through rock, expanding volumes, dissolving minerals, and even triggering earthquakes. These fluids can travel great distances, seep into fractures, and suddenly pressurize entire underground cavities. And if they do this fast enough, or at the right depth, they can deform the land above just as effectively as rising magma. This theory has gained traction in recent years thanks to advances in geothermal research. Iceland, after all, is a hotspot, both figuratively and literally, when it comes to geothermal energy. Beneath its surface lies a labyrinth of hydrothermal systems, boiling reservoirs, and underground aquifers supercharged by volcanic heat. These systems power homes, heat cities, and drive turbines. But they're also dynamic and volatile, constantly shifting, expanding, and evolving in response to both human activity and natural forces. Scientists studying geothermal reservoirs have observed instances where the injection or withdrawal of water caused minor quakes, shifted faults, and even lifted the ground. But now, attention is turning to something much larger, far deeper, and entirely natural: a massive subterranean migration of fluids, on a scale never before observed beneath Iceland. What makes this theory even more compelling is the peculiar seismic signature of the recent tremors. Many of the quakes aren't sharp and abrupt, like classic tectonic quakes, nor do they match the deep, rhythmic tremors often associated with magma movement. Instead, they're long-period events, a slower, rolling type of quake often linked to the movement of fluids through porous rock. These tremors tend to originate from intermediate depths, somewhere between the crustal layers that hold magma and the shallower zones where tectonic stress builds. It's a geological gray area, difficult to image and even harder to study, but increasingly, the data is pointing towards some kind of pressurized intrusion, not of molten rock, but of liquid and vapor. And if superheated fluids are the true cause, then we may be witnessing the rise of a new kind of hazard. As these fluids force their way upward, they can weaken rock formations, lubricate ancient fault lines, and create a pressurized environment ripe for sudden failure. In essence, they can trigger quakes indirectly by altering the underground stress fields. But they can also generate surface uplift, slow, dome-like inflation as underground reservoirs expand. This matches closely with what GPS stations are detecting near the Reykjanes Peninsula, a swelling of the land that's too gradual and widespread for a single magma pocket, but too sustained to be purely tectonic. And unlike magma, these fluids leave behind fewer thermal traces. They can move undetected until they're already in motion, like a hidden tide reshaping the foundations of the island. Some scientists have even begun drawing comparisons to hydrothermal eruption events, violent explosions that occur when water trapped beneath a cap of rock suddenly flashes to steam. These events are rare, but they've happened in places like Yellowstone and New Zealand. Could Iceland be next? Could these migrating fluids, trapped beneath layers of dense volcanic rock, one day reach a tipping point and unleash a catastrophic explosion. It's not a theory anyone wants to test, but it's one that cannot be ruled out. Further complicating the picture is the possibility that this massive fluid movement is not a new phenomenon, but part of a much larger subsurface cycle, one that occurs every few centuries but leaves behind few visible records. Iceland's deep history is written in lava flows and ash layers, but what of the hidden hydrological systems that may have surged and ebbed over time, quietly triggering collapses, eruptions, or strange deformation patterns that went misunderstood by earlier observers? We may be standing on the edge of uncovering a long-lost rhythm of the Earth, one that pulses through the crust not with fire or fracture, but with water under unimaginable pressure. So, while the idea of supercritical fluids migrating beneath Iceland might sound obscure, it could very well be the missing piece of the puzzle. It's a theory that defies easy categorization, either purely volcanic nor purely tectonic, but something in between. Something stealthy. And as we gather more seismic data, pressure readings, and satellite imagery, a new image is starting to emerge: a subterranean flood, invisible and untethered, shaping Iceland from the inside out. And yet, as we peer further into this enigmatic underworld of Icelandic geology, the theory of subterranean fluid migration grows only more complex and more fascinating. Because it's not just that fluids might be moving underground, it's how they're doing it that's raising eyebrows among the scientific community. You see, these aren't just aimless streams of hot water bubbling through cracks. They're part of a larger, self-reinforcing cycle of pressure buildup, chemical interaction, and deep earth mechanics that may be slowly transforming the crust of Iceland from the inside out. To begin with, there's the phenomenon of mineral dissolution. When superheated water, infused with gases like carbon dioxide, sulfur dioxide, and hydrogen sulfide, permeates through volcanic rock, it doesn't pass through passively. It dissolves minerals, widens fractures, and gradually alters the physical composition of the rock itself. These processes can create vast, pressurized reservoirs filled with mineral-rich fluids, acting almost like balloons buried beneath the surface. Over time, as more fluid is drawn into these zones, either from deeper magma sources or from existing geothermal pathways, they swell. The rocks surrounding them begin to strain under the pressure, eventually warping or even fracturing in ways that echo across the entire crust. These deformations are subtle, often undetectable at first, but when they occur across a large area, they can reshape entire regions of land. Now consider the role of phase transitions, a process where that supercritical fluid, already in a volatile state, suddenly flashes into steam due to a slight pressure drop or a change in permeability. This instant transformation creates a surge in volume, which can act like a mini detonation within the Earth. The surrounding rock absorbs the shock, transmitting it outward as seismic waves. And while these aren't your typical sharp, high-frequency earthquakes, they produce a specific type of seismic signal that has increasingly shown up in Iceland's recent activity: subtle, tremor-like disturbances that lack a clear source or rupture zone, but ripple outward nonetheless. It's like hearing a deep, distant rumble, without knowing where the thunder is coming from. But what makes this particularly challenging for scientists is that supercritical fluids don't follow the rules of conventional geology. Unlike magma, which is relatively slow-moving and thermally traceable, or tectonic stress, which follows long-known fault lines, these fluids can creep, surge, or even pulse through rock layers depending on pressure gradients, permeability, and temperature shifts. One moment they may be stagnant, trapped within impermeable boundaries. The next, a sudden shift in local stress or a minor quake might fracture a barrier, allowing them to rush into new areas and trigger a cascade of reactions, each more unpredictable than the last. In fact, some researchers suspect we might be witnessing the early stages of such a cascade right now. Satellite imagery has revealed slow, consistent ground uplift across multiple regions of the Reykjanes Peninsula, not just in one concentrated zone, but spread out over a wide area. That's unusual. Magma tends to create focused inflation directly above its chamber. But this broader swelling hints at something more diffuse, like a rising, underground tide. Coupled with the unusual chemistry changes in some geothermal wells, such as a sudden spike in sulfate or silica levels, scientists believe fluid reservoirs are shifting. They may be expanding. They may be merging. And if those reservoirs reach critical pressure, or encounter a weak zone in the crust, the resulting surge could destabilize large sections of Iceland's foundation in ways that we still don't fully understand. Moreover, there's a growing concern about the feedback loops that such a system might create. For example, if fluid pressure triggers a quake, and that quake fractures new pathways, it can allow even more fluid to rush in, fueling additional uplift, more quakes, and further expansion. This runaway scenario could theoretically continue until something ruptures. It may not end in an eruption, but it could still pose serious risks to infrastructure, geothermal plants, and nearby communities. Roads might buckle. Pipelines could shift. Groundwater systems might become contaminated or redirected, creating cascading effects both above and below ground. And here's something that truly raises the stakes. We've barely begun to map these systems. Despite Iceland's reputation as a well-monitored geological hotspot, many of these deep fluid reservoirs lie beyond the reach of current seismic imaging. Traditional monitoring tools were designed with magma and fault zones in mind, not with amorphous, migrating pockets of pressurized fluid. So while researchers scramble to adapt their models and refine their instrumentation, there's a sense that we're staring into a black box, something large, dynamic, and hidden, reshaping the Earth without a clear warning. In the end, what makes this theory so unnerving is not just its plausibility, but its silence. Unlike volcanoes that spew smoke or earthquakes that shake the ground with thunderous clarity, fluid migration operates in whispers, in tremors, in chemical signatures, in slow, silent swelling. And if this process continues unchecked, it may lead to a moment when the land suddenly reacts, not with warning, but with surprise. As scientists struggle to explain the deep and unusual movements beneath Iceland, some researchers, particularly those on the fringes of mainstream geology, have dared to explore an altogether different possibility. It's a theory that treads the line between science and mystery, between accepted models and uncharted phenomena. And while it's far from proven, it's beginning to gain whispers of attention in specialized corners of the scientific world. The idea that an unknown anomaly in Earth's mantle, perhaps a slow-forming georeactor or an exotic mineral core, is creating a localized gravitational distortion beneath Iceland. To understand how such a bizarre theory could even be entertained, you have to appreciate the uniqueness of Iceland's location. Sitting squarely on the mid-Atlantic ridge, where the Eurasian and North American tectonic plates diverge, Iceland already exists in one of Earth's most geologically complex zones. The crust here is thinner, the mantle plume is hotter, and the geological activity more extreme than almost anywhere else on the planet. So if anywhere we're going to host an anomaly, something unknown, something different, this would be the place. Now, proponents of this theory believe that the recent seismic patterns and uplift can't be fully explained by magma or fluid movement alone. What they propose instead is that a slow-forming mass deep within the Earth, possibly composed of ultra-dense materials, like iron-nickel alloys or even rare radioactive elements, has begun to subtly influence the gravitational balance in the region. Think of it like a concealed weight, buried miles below, warping the flow of molten rock and the movement of tectonic plates above it. The presence of such a mass could create localized density variations in the mantle, altering convection currents, and causing unusual vertical shifts in the crust. There's even talk of a natural georeactor, a theoretical pocket deep in the Earth where radioactive elements accumulate and self-regulate nuclear fission, much like an underground power plant. While that might sound like science fiction, it's worth noting that such a phenomenon has occurred before. In Gabon, Africa, natural nuclear reactors operated nearly 2 billion years ago under specific geochemical conditions. The Icelandic anomaly, some speculate, could be a modern counterpart, just beginning to awaken, subtly heating the surrounding mantle and shifting the overlying land in unpredictable ways. The gravitational implications of such an anomaly are equally strange. Some satellite-based gravity measurements over Iceland have revealed tiny fluctuations, milligal-level deviations, that don't align with any known surface features or volcanic structures. While officially attributed to seasonal ice melt or magma chamber dynamics, a fringe group of researchers wonders if these anomalies point to a deeper, denser source. If true, it would mean the ground is not just moving because of pressure, it's moving towards something pulling it from below. Adding to the mystery are reports, still anecdotal, still unofficial, of magnetic field disturbances in the region. Iceland's magnetic readings, normally stable, have shown faint pulses and fluctuations that don't correspond to solar activity. Could it be the influence of some magnetic source deep within the Earth, slowly building in strength? Could we be watching the early formation of a new magnetic pole fragment, what some geophysicists call a dipole drift event? If so, the crust reaction might not just be vertical swelling, it could also include lateral stress, invisible to the eye but building silently across the region. And here's where it gets even more speculative. A handful of rogue thinkers suggest that if such a mass exists, and if it is rotating differently than the mantle around it, it might be creating a localized torsion effect. This could generate subtle vibrations or torque stress in the crust, mimicking earthquakes or uplift patterns without a traditional tectonic cause. The idea is still extremely controversial, bordering on the fringe, but it's captivating in its implications. It suggests a kind of buried dynamo, a self-contained energy source that's been slowly ticking away for millennia, only now beginning to affect the land above. What would the implications be if this theory held even a shred of truth? For one, it would fundamentally challenge our understanding of plate tectonics, mantle dynamics, and Earth's internal energy distribution. It might even imply that our planet has more internal variability than we've ever imagined, regions where strange, slow phenomena can quietly rewrite geological norms. And if such a geodynamic anomaly can exist beneath Iceland, what else might be lurking beneath our feet elsewhere, undetected, unexplained, and slowly changing the world? While mainstream science continues to focus on magma flow and crustal stress, this shadow theory remains on the sidelines, half mystery, half marvel. But in a world where the ground itself is shifting, where satellites are picking up signals that don't match any familiar patterns, and where the Earth occasionally reminds us just how little we truly know, even the wildest ideas can begin to feel eerily plausible. As we look into the bizarre, inexplicable movements beneath Iceland, the real question becomes, what could all of this mean for the people who live there? The residents of Iceland have always lived with a certain understanding of their environment. For generations, they've dealt with volcanic eruptions, geysers, hot springs, and earthquakes, a landscape where the Earth constantly seems to be reshaping itself. Icelanders have learned to coexist with this raw, dynamic force. But what happens when the shifting beneath their feet takes on a new dimension? At first glance, the changes beneath Iceland might seem like another natural occurrence, a regular part of life in a country shaped by volcanoes and geothermal energy. But this ongoing pattern of seismic activity, the mysterious uplift, and the unexplained gravitational anomalies could signal something bigger, something more ominous on the horizon. If the shifting beneath Iceland is indeed the result of a larger, more powerful geophysical event, the implications could be far-reaching for the island and beyond. Let's start with the most immediate concern, volcanic eruptions. Iceland sits atop a hotspot known as the Icelandic mantle plume, which has given rise to some of the world's most active volcanoes. If the forces beneath the Earth's surface are changing in ways we don't fully understand, it could lead to increased volcanic activity. Some scientists have already pointed out the possibility that the tectonic shifts happening beneath the island could trigger eruptions in previously dormant volcanoes or cause rapid changes in existing ones. In the worst-case scenario, if a massive eruption were to occur, the consequences for Iceland could be devastating. Ash clouds could disrupt air travel across Europe, much like the 2010 eruption of Age of Geological did, but on a much larger scale. The ash and gases spewed into the atmosphere could affect global weather patterns, potentially leading to a temporary cooling of the Earth's climate. The island itself could face widespread destruction, with homes, infrastructure, and entire communities at risk. Crops could be destroyed, livestock affected, and the economy, which heavily relies on tourism, geothermal energy, and fishing could be plunged into turmoil. Then there's the potential for environmental shifts. If the underground forces beneath Iceland are, as some suggest, part of a slow-moving georeactor, the consequences for the land could be unpredictable. Over time, this anomaly might cause geothermal energy pockets to behave in unexpected ways, leading to unpredictable ground heating or even land subsidence. This could disrupt Iceland's delicate balance of natural resources, particularly its rich geothermal energy reserves that the country relies on for heat and electricity. But even if the scenario isn't as catastrophic as a volcanic eruption, the social and economic consequences of the shifts beneath the surface could still be significant. Iceland's tourism industry is a major economic driver, attracting millions of visitors who flock to see the island's volcanic landscapes, glaciers, and hot springs. However, if the land begins to behave in more unpredictable ways, with frequent tremors and unexpected ground movements, tourists may become wary of visiting. Hotels, tour companies, and local businesses could suffer as a result. Perhaps one of the most unsettling implications is how this shifting land could affect daily life for Icelanders. Imagine a scenario where tremors become a regular occurrence, or where landslides and earthquakes increase in frequency and severity. For residents, this could mean adapting to new, possibly dangerous realities. Buildings might need to be reinforced, and infrastructure might need to be redesigned to withstand the constant movement of the ground. The government would have to invest heavily in monitoring systems, evacuation plans, and disaster preparedness measures. And it doesn't stop at the physical dangers. The psychological toll on the population should not be underestimated. Living with the constant knowledge that the earth beneath you is shifting in ways that you can't fully understand can have a profound impact on mental health. The stress of living in a seismically unstable environment, especially if the frequency of earthquakes and tremors increases, could take its toll on communities. However, even though Iceland might be facing a time of unpredictability, there's still hope. The country's resilience, born from centuries of living alongside unpredictable nature, could be its greatest asset. The people of Iceland have always adapted to change, whether through volcanic eruptions or seismic shifts, and have proven time and again that they can recover and rebuild from even the most catastrophic events. The expertise of Iceland's scientists and engineers, particularly in areas like geothermal energy, could help mitigate the risks posed by these mysterious shifts. Beyond Iceland's shores, however, there are also implications for the global community. Given the strategic location of the island in the North Atlantic, any geophysical change in Iceland could disrupt shipping routes, air traffic, and even global climate patterns. If the island's volcanic activity increases, there could be a ripple effect that influences nearby nations, particularly those in Europe. Geothermal research in Iceland could also change the future of renewable energy, as the island's unique positioning allows for cutting-edge exploration into new forms of energy production. What's perhaps most striking is how the situation in Iceland might prompt the scientific community to rethink geological models as a whole. If the theories surrounding the current shifts are proven true, whether it's the presence of an exotic underground anomaly, a strange gravitational force, or something more unpredictable, it could force us to revise our understanding of how Earth's crust works, and how even the smallest disturbances beneath the surface can have massive, cascading effects. As we close the chapter on this intriguing journey beneath the surface of Iceland, it's clear that the mystery of what's happening deep within the Earth's crust is far from being solved. The theories we've explored, ranging from shifts in tectonic plates to volcanic reactions, mysterious gravitational forces, and even speculative ideas like hidden alien activity, offer just a glimpse into the complexities of our planet's dynamic nature. What we do know is that Iceland, as an island forged from fire and ice, is an epicenter of constant geophysical change. The question remains, how much of this is natural, and how much is something new? The residents of Iceland have witnessed firsthand the power of nature and have learned to coexist with its unpredictable rhythms. Yet, as the ground beneath their feet shifts and shakes in ways never fully understood, there's a palpable sense of unease in the air. Could these anomalies be a sign of something even more extraordinary? A warning that the land is changing in ways we can't yet predict? Or is this just another chapter in Iceland's long history of seismic activity, a chapter that we've yet to fully understand? What stands out most about this situation is how much of the planet's inner workings remain a mystery. While science has come a long way in deciphering the complex mechanisms of our Earth, there's still so much that we don't know. We understand the general principles of plate tectonics, magma movement, and volcanic activity, but the true causes of these shifts, especially the unexplained ones, continue to elude us. And for the people of Iceland, this uncertainty is not just academic, it's personal. Their way of life, their homes, and their livelihoods are intricately tied to the land beneath them. Every tremor, every rumble from the depths, brings with it the possibility of change, some welcome, some not. But amid the uncertainty, there is also hope. Iceland has a long history of resilience in the face of natural disaster. From volcanic eruptions to blizzards, Icelanders have shown time and again that they are not easily defeated by nature's wrath. They have adapted to the challenges posed by living in such a dynamic environment, developing sophisticated technology and disaster response strategies that could help them navigate whatever lies ahead. The same volcanic activity that once threatened the island is now harnessed for renewable geothermal energy, which is a global model for sustainable power. This resilience, paired with Iceland's forward-thinking scientific community, means that no matter what lies beneath, the people of Iceland will continue to find innovative ways to live in harmony with their surroundings. The implications of the shifting land in Iceland reach far beyond its borders. The island's position in the North Atlantic makes it a critical player on the global stage. Changes in Iceland could potentially impact global shipping lanes, air traffic, and even climate patterns. As scientists continue to monitor the situation, the rest of the world will be watching closely, perhaps even rethinking how we approach geological science. This unfolding situation serves as a reminder of how little we truly know about the forces that shape our planet. Just as Iceland's land is constantly evolving, so too is our understanding of the Earth, and that's something that should fuel both awe and caution. But the real takeaway from all of this, perhaps, is the deep interconnectedness of humanity and the natural world. As much as we build and innovate, we remain at the mercy of the forces beneath our feet. This mystery in Iceland is a humbling reminder that no matter how far we progress in our understanding, there is always more to discover. The planet is full of surprises, some that we can explain, and others that leave us wondering if we'll ever truly understand what lies beneath. For now, Iceland stands at the center of this enigma, a land where the Earth is in constant flux. But even if the answers to these mysteries remain out of reach for the time being, one thing is certain: Icelanders will continue to watch the ground beneath them with both reverence and caution. As for the rest of us, we'll continue to watch as well, fascinated by the shifting landscape and eagerly awaiting the next revelation in this extraordinary natural drama unfolding beneath Iceland. In the end, whether it's the shifting tectonics or something even more extraordinary at play, the story of Iceland's mysterious transformations reminds us of the Earth's power, its beauty, and the unpredictable journey it takes us on. We may never have all the answers, but perhaps the thrill of the unknown is what keeps us looking, questioning, and marveling at the strange wonders our planet has to offer. If you've found this journey beneath Iceland as fascinating as we have, don't forget to like this video and subscribe to our channel for more deep dives into the mysteries of our world. The forces beneath our feet may be hidden, but together, we can explore the unknown. Stay tuned for more intriguing stories, and remember to hit that bell so you never miss an update. Until next time, keep wondering, keep exploring, and stay curious.